This is an area volume type problem. Part A asks us to find the area of R. So then part A, finding the area of R, I would start by drawing the representative rectangle. And then the height of that representative rectangle is going to be top curve minus bottom curve. The top curve is g of x minus the bottom curve is f of x times the width of that rectangle is dx, which gives me the area of that one rectangle. And then I would sum up the area of all the rectangles from 0 to the point of intersection. And we're going to use our calculator to find the point of intersection. In y equals, I have f of x in y1 and g of x in y2. So then I'll set my window. The window was a little bit of a guess, 0 to 1.5. For the y is a little less of a guess. The max of sine is going to be 1 plus 1/4, so the max y value is 1.25. And then knowing my max y value, putting 0 to 1.5 for my x's and then adjusting that window if I needed to adjust it. So hit graph, here's the graph. Looking for that first point of intersection. We're going to calculate that point of intersection. So second, calculating the intersection, enter, and then my guess, I'm going to guess 0. So I get that point of intersection that's on the left, and I get this 0.178. And now that value, that 0.178 is stored in x. So then I'm going to let my upper limit be that 0.178. So integrating from 0 to that 0.178, and I can use this variable b for 0.178 through the rest of the problem. But I do have to state on my paper that from now on b is going to be 0.178. So this is going to be the area of R, and we're going to use our calculator to find this area. I want to remind myself that y1 is f of x and y2 is g of x. So I'm doing g of x minus f of x, so y2 minus y1. So math 9, from 0 to the value that's stored in x, and from y2 minus y1, g of x minus f of x, integrated with respect to x, and I get this 0.065. So 0.065 is my area. Then finding the area of region S. The area of region S, again drawing the representative rectangle. The height of that representative rectangle is going to be top curve minus bottom curve, so this time f of x minus g of x. Integrating from that point of intersection to that second point of intersection, we can figure out what that second point of intersection is going to be, again using the calculator. Second, calculate, intersect, enter. This time I'm going to make a guess that is a little bit closer to that other point of intersection. So let me trace to the left. The second point of intersection happens to be 1. So then integrating from that 0.178 to 1, letting the calculator do that. Letting the calculator do this integration. I have to be careful here because now 1 is stored to x. So I want to make sure that I get this other value, that 0.178, and I store it back to x. So now I can do my integration, math 9, from that 0.178 to 1. This time f of x minus g of x, so this time y1 minus y2, integrated with respect to x, and that gives me this number, this 0.410. So equals 0.410. And then on to part C. Part C is saying that if we have some line y equals -1, and we rotate region S around this line. So here's our axis of revolution. We want to find the volume of the solid created. And this space between the axis of revolution and the region that we're rotating tells me that this is going to be washer method. So here is my washer. Here is my axis of revolution, which is y equals -1. And then here is the space between the axis of revolution, and here is my representative rectangle that created the solid part of the washer. And the way that I would find the area of a circle with a circle missing is going to be pi r outer radius squared minus pi r inner radius squared. So pi r, the outer radius, is going to be the distance from the center to the outer circle. So the distance from the center to the outer circle on our region is this distance. And top curve minus bottom curve is going to be f of x minus a -1. So f of x plus 1. And then minus pi times the inner radius squared. The inner radius is going to be the distance from the center to the inner circle, which on our region is this distance here, which is g of x minus a -1, or g of x plus 1. So that's the area of our cross section, and to turn that area into a volume, we would integrate. And we're integrating region S, so we're integrating from this value b to 1. And this one actually says find the volume, so the way we're going to find that volume is plug into the calculator. Also, we have a constant multiple pi, so we can bring that constant multiple out of the integration. So f of x plus 1, the whole quantity squared, g of x plus 1, the whole quantity squared, integrated with respect to x. Common mistake here, a few common mistakes: forgetting the pi, not doing the outer radius squared minus inner radius squared. A lot of possible things that we could do to, a lot of common mistakes. So using our calculator here, math 9, we're going to integrate from that value x to 1. And I need my outer radius squared, so parentheses, f of x. I stored f of x into y1. So this is going to be alpha f4 y1 plus 1, that whole thing squared, minus inner radius squared, alpha f4 y2 plus 1, that whole thing squared, integrated with respect to x. Enter. And we get this value. Oh, common mistake, I forgot to multiply by pi. So times pi. And we get this value is 4.559. So that is our volume. Equals 4.559. The points for this problem, they come from pretty much the same thing for every part of the problem. Is the integrand correct? Are the limits correct? Is the final answer correct? Is the integrand correct? Are the limits correct? Is the final answer correct? For this last problem, 2 points for the integrand. So did I have the correct radii for the inner circle and outer circle, and did I subtract them? And then are my limits and constants correct, which is to say, did I get my limits correct, and did I forget to write the pi, or did I remember to write the pi? And then is my final answer correct here as well? I think that's where the last points came from. Maybe on this one, maybe there was just 1 point for the integrand, and then the final answer.